Turner here with a short lesson on simplifying square roots. Our learning target is I can simplify a square root.
All right, go ahead and add SQ3, simplifying square roots, to your table of contents. You probably haven't seen simplifying square roots since 8th grade in the Pythagorean theorem, so we're going to go over some basic vocabulary first. This little division symbol that has a tail on the end of it, that is called the radical sign. And the number that is outside the radical sign is called the index. Now, a word not used very often is radicand, and that is the number that is underneath the radical sign. To simplify a radical, it means to write it in another form, which is equivalent to the given radical. It is just simpler to use in higher math. A quick note here, the index that we are most used to is the square root. If no index, then that is the square root. Okay, so I've said before, us mathematicians are a little bit lazy, and we do not write a 2 there. That just equals the square root. Now, a square root is in simplest form. We are worried about simplest form. Many of our answers will be required to be written in simplest form. When the radicand contains no perfect square factors, an example of that is the square root of 2. The only factor of 2 is 1 and 2, and neither are perfect squares. The radicand is not a fraction. So again, that is a whole number under there. And there are no radicals in the denominator. Remember, the denominator is downstairs. So you can have a fraction. Let me give you an example here. If we have the square root of 3 over 5, that is in simplest form because the radical is in the numerator, not the denominator. So how do we do this? First of all, you find the largest perfect square that is a factor of the radicand. Okay, so what does that mean? I'm going to look at 48 here. And when I look at 48, makes you dizzy. When I look at 48, I have a 16. That is the largest perfect square. Note, 4 is also a perfect square, but 16 is larger. So I am going to rewrite this as the square root of 16 times the square root of 3. Now, the square root of 16 is 4, and we're going to leave the square root of 3. This is giving you an exact answer in simplest form. Let's try it again. 45. 45 has factors of 9 times 5. So I am going to rewrite it as the square root of 9 times the square root of 5. The square root of 9 is 3, and I have a square root of 5. Now, when you look at the factor tree for the square root of 26, let's just do that. I'm going to slide over the square root of 26. There are no perfect squares here. There are none. So guess what? When we go back over here, we just write that this is already in simplest form. It doesn't get any better than that. The square root of 60, now that one, example 4, is not written in simplest form. Go ahead and pause the video and see if you can get the correct answer. Okay, 60 is a factor of 4 times 15. 4 is your perfect square factor of 60. So when you break that apart, root 4 times root 15, you get 2 root 15. I hope this helps simplifying radicals.
How are you feeling about this? This is one of those skills that the more you practice, the easier it will get. Make sure you have your factor chart ready. And now, it's a great time to do some math.